Alright, this is Roger Timmerman McLean for Dr. Nasseri's Manufacturing Processes class. It's summer of 2011. I'm going to do chapter 4, problem number 2. Basically, paraphrase the problem. What we've got is they gave us a jar, and I sort of drew it out here to just so we can get an idea what's going on. We've got a jar, and it's got a lid on the jar that's nickel. And that the lid is got a diameter of 7 centimeters. What we do is we place that jar under some water, some hot water. We make sure that hot water hits the center of the jar because we're trying to heat up that jar, that lid. So we make sure the hot water hits the center of the lid. And what it's asking us to calculate is it tells us that the lid had an initial temperature of 20 degrees Celsius. The hot water heated it up to 60 degrees Celsius. So we want to know what's the what expansion occurs in that lid, that nickel lid. Straightforward problem. We can solve for the change in diameter using this equation here. It says change in length is equal to coefficient of thermal expansion times the initial length times the change in temperature. So to kind of adjust this for our purposes, we can just say instead of change in length, we can just say change in diameter is equal to coefficient of thermal expansion for nickel times original diameter times change in temperature. For our situation. It's just rewriting this equation for the information that we're given. So change in diameter is equal to the coefficient of thermal expansion for nickel. Coefficient of thermal expansion is a material dependent property that can be looked up in any engineering reference manual. In this case, they actually gave it to us, and they told us that that was 13.3 times 10 to the minus 6 inverse degrees Celsius. Diameter, original, we know 7 centimeters. And the change in temperature, the lid was initially 20 degrees, it goes to 60 degrees, so it's a change of 40 degrees. All right, it's change in diameter. So crunch the numbers, and our change in diameter is going to be equal to 0.0037 centimeters. Just making sure our units work out here. Yes, it did. Centimeters. And so that's our answer. The change in diameter is 0.0037 centimeters. Really small number. That tells us that our D2, our diameter moved from 7 centimeters to 7.0037 centimeters. Definitely not a value that you can detect with the eye, but hopefully you can feel it and you can get that lid off the jar. Everyday problem as engineers using our knowledge of material properties, and we can go ahead and explain why why this process works. Heating up a jar lid can get the lid off the jar. All right.